In the last video, we explored decision making by examining the roles of various brain regions within the human cognition and compared them to decision making, that how it might work in LLMs versus potential future of AGI. Now today we are discussing still decision making, but at the brain waves level, the electrical activities of the brain, which brain waves frequencies are involved when it comes to decision making in the human brain, and still doing a comparison with how that potentially look like in LLM versus the future of AGI. Human decision making is deeply intertwined with brainwaves activities, which reflect different cognitive states during complex choices. Brainwaves, which are measured as electrical impulses within the brain, are categorized into 5 primary frequencies: delta, theta, and so forth. Each of these frequencies play a distinct role in cognitive functions like attention, memory, reasoning, and so forth, which are essential for the decision-making processes when it comes to us as humans trying to make decisions. When it comes to theta waves, which are the lowest frequency within the brain, they are considered more or less the reflective stage of the decision-making. For example, they are associated with states of relaxation, sleep, and so forth, but they do play a significant role in decision making. According to some research, theta activities have been observed during tasks that require deliberation and intuitive decision making, and different studies, some of which were done back in 2012, suggest, for example, that theta waves are crucial in the process of evaluating alternatives, reflecting on past experiences, and generating solutions when faced with ambiguous situations. The theta rhythms is to facilitate access to memory and emotional processing, allowing individuals to feel their decisions or intuitively select the best course of action. For example, theta synchronization in the prefrontal cortex have been linked to integration of emotional states and cognitive appraisal during decision-making tasks. This process enables decisions that combine rational thinking and emotional information. Alpha waves are more considered the focus and clarity stage within the human decision making. They're often dominant during states of relaxed alertness, and these waves are crucial when individual is actively engaged in focusing and filtering irrelevant stimuli when making a decision. Research, for example, by Muller, found that alpha desynchronization is a key marker for decision-making processes, especially when focusing on a task and considering different options. Alpha activities then in the prefrontal cortex aid to reduce mental noise, enhancing the clarity of thought and facilitating the conscious evaluation of choices. During decision making, alpha waves frequencies support the suppression of distractions and allow the brain to focus on the task at hand. It is believed that alpha waves attenuation help prioritize relevant information and vital process when decisions are required that involve evaluating risks or long-term outcomes. Beta waves are considered more or less the active thought and rationality when it comes to the decision-making process within humans. They are strongly associated with active thinking and problem solving. In the context of decision-making, as an example, beta waves are particularly prominent when an individual is engaged in tasks that require logic, reasoning, and rapid decision making. For example, there were some studies done back in 2007 where beta waves had been linked to goal-directed behavior and cognitive control, especially when individuals must make quick decisions under pressure to time constraint. In particular, beta activity in prefrontal cortex is associated with the ability to engage in working memory and executive functions such as inhibitory control and planning, both of which are essential when analyzing multiple options. Beta waves provide the mental energy needed for conscious evaluation of the consequences of various choices, making them essential for decisions involving higher order thinking. Gamma waves, which are the highest frequency within the human brain, they are considered more higher level cognitive processing when it comes to decision making. They are the fastest of the brainwaves frequencies, and they are linked with complex cognitive processing and information integration. These high frequency waves reflect the brain's ability to synthesize and integrate diverse sensory inputs, thoughts, and emotions, which are crucial when making sophisticated decisions. For example, Jensen et al. Back in 2007 posited that gamma activity in the frontal and parietal regions of the brain play a significant role in coherent thought processes during decision making, particularly for tasks that require synthesis of different streams of information. When making decisions, for example, gamma waves support attention and conscious awareness, facilitating the human decision making that require the integration of emotion, sensory data, and memory. As such, gamma synchronization has been suggested as a key mechanism in the human brain's ability to integrate complex information, leading to better informed and more coherent decisions. Now, when it comes to LLMs, as mentioned in the past, in contrast to the human brain, the LLMs do not operate using brainwaves frequencies, and they do not possess the way we inherently as humans make decisions. Instead, they function through algorithms that they rely on training data patterns and statistical relationships between words. LLMs are trained to generate output based on the probability distributions, but they do not have the ability to engage in the same complex reflection or emotional processing that humans do during the decision-making processes. As LLMs are based on artificial neural networks, their decision-making process lacks the neural oscillation that corresponds to specific brainwaves frequencies. They process inputs and generate outputs in a purely computational manner without consciousness, intuition, or emotional regulations, making their decision making fundamentally different that of humans. What about AGIs? The potential development of AGIs in the future, next generation AIs, could introduce systems capable of emulating human-like decision-making processes, including the use of some of the cognitive processes that we mentioned. AGI would ideally need to stimulate decision-making processes that integrate rational analysis, emotional intelligence, and intuitive reasoning, the same process that rely on complex interactions of different brain regions and different brain waves within the human brain. Now, to develop AGI, future potential future next generation AI capable of decision making, the system might need to stimulate these type of integration of cognitive functions that is happening within the brain. They would require, for example, neuromorphic computing architecture that replicate the functions of the biological brain, allowing machines to process and synthesize information in a manner that mimics the human decision making at a fundamental cognitive process level. In these video series, we are looking at the specific characteristics in which the human brain works, and we compare that with the current generation of AIs, as in LLMs, in comparison to future generations of AIs, potentially AGI. So far, we have covered reasoning and decision making, the way in which the human brain operates. Next, we are going to cover the emotional intelligence. These are the ways in which the human brain differentiates itself from artificial intelligence. And when it comes to emotional intelligence, in the next video, we're gonna cover the brain regions that are involved. And then in the following video, we're gonna look at the brain waves that are involved in emotional intelligence. I hope you found this video helpful. Thanks all for the likes and comments. I really appreciate it. And feel free to share the videos if you find them useful. Thanks. Bye.